Okay, so we're looking at angles that are formed by secants and tangents. Now, if you remember, a tangent is a line that intersects the circle at one point. That's a tangent. A tangent is a line that intersects the circle at one point. Then you've got a secant, which is a line that intersects the circle at 2 points. So that's your tangent and your secant. So let's review here the kinds of angles we talked about. First angle we've talked about here is when it's in the center. That is called a central angle, okay? So this is your central angle. And we've talked about central angles. Central angles are angles whose vertex is in the center, okay? Now the central angle, okay, remember the central angle has the same measure as the arc it intercepts, honey. Not right now.
She said she was gonna break my jimmy.
Go lay down and I'll come get you in a minute. As the arc it intercepts. Okay, so the central angle, love kids. I do, I really do. Central angle has the same measure as the arc it intercepts. So let's look at the circle. The circle has 360, okay? The circle, it measures 360. Well, this arc from here to here is 200. So since that arc is 200, and you know the whole circle is 360, I'm going to do 360 minus 200, and that's going to give me 160 degrees. So that means this arc is 160 degrees. Now remember, the central angle has the same measurement as the arc it intercepts. So in that case, that means that x is actually 160 degrees. So this is also 160. So that's your central angle. Now let's review the next one that we just talked about, called the inscribed angle. So this is an inscribed angle. And if you remember, the inscribed angle is 1/2 the measure of the intercepted arc. It's not the same, and again, the intercepted of the arc it intercepts. I know I'm going off the paper a little bit. I'm probably going to zoom out so you can see it a little bit better. Let me zoom out a little bit. There we go. So the inscribed angle is 1/2 of the arc. So it's inscribed because its vertex is on the circle. So if this arc is 140, I swear my kids are fighting, I'm so sorry. If this arc is 140 and this arc is 170, again, what do you know the entire angle, the entire circle adds up to? The entire circle adds up to 360 degrees. So if that's 170 and that's 140, that adds up to 310 degrees. So that means this arc right here is 360 minus 310, which is 50 degrees. So that means this is 50 degrees. That means that this arc is 50 degrees. Now, the inscribed angle is 1/2. 1/2 of the intercepted arc. So since the intercepted arc is 50 and this is inscribed, that means the arc itself, the inscribed angle is 25 degrees. So we're just kind of reviewing what we've done the past couple of days. All right, so now let's look at some brand new theorems here. Okay, hopefully we can get them in the picture. All right, we've got a couple of new theorems. The theorems say if a secant...
I want to stay out in the living room.
Okay, go to your bed for right now, honey. I'll be there in a minute. Says the theorem is if a secant and a tangent intersect at the point of tangency, if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So what you see here, the vertex is on the circle, just like the inscribed angle, right? But this is not inscribed because look at this piece. This is a tangent. Basically, you have a tangent line. What is a tangent line? It intersects one point of the circle at the point of tangency. And you have a secant line. This is your secant. Because that's actually a chord, but they call it a secant because you assume it goes through like this, okay? So if a tangent and a secant, and I'm going to draw this line here, a secant intersect, then the measure of this angle is 1/2 of the intercepted arc. Well, what is the measure of the angle? 30 degrees. Well, what's the arc it intercepts? Well, you see it with the dotted line, and I'm going to fill it in. That means it's double, so this arc is going to be 60 degrees. Once again, when you have a secant and a tangent, or a tangent and a chord intersecting, and the vertex is on the circle, The vertex is on the circle. Notice the connection here with both of these. Both the inscribed and the angle on the circle are both vertex on. They're also both half. Do you see that? This angle is on the circle, it's half this one. This angle is on the circle, it's half this arc. On the circle vertex, half the arc. On the circle vertex, vertex on the circle, half the arc. I'm going to say it one more time. If the vertex is on the circle, half the arc. Okay? So let's move on to the next one. All right.